Okay, today, instead of using our tables to graph our quadratic functions, we're going to use, let's first start with talking about the y-intercept, because that's one of the points that we're going to use to help us do the graphing. So the y-intercept, you're going to be able to count on if the quadratic equation, the quadratic function, is written in standard form, and we know what standard form is. If the quadratic function is written in standard form, you can count on that c value, which we're familiar with also, because of factoring quadratics, we know what the c value is. It's the constant. Remember, standard form for a quadratic equation is y equals ax squared. Finish it for me. Plus bx plus c. Okay, that c value you can count on is always going to be the y-intercept. It's going to be the y value where the parabola will cross the y-axis. So to graph a quadratic function today, we're going to use the vertex, we're going to use the y-intercept, and we're going to use symmetry. And I say you need to have at least 5 points. Now you notice in those ones that you graphed for today in the tables, they had sometimes 7 or 9 points for you to do. Today I will let you off the hook with just 5. So graph y equals x squared minus 6x plus 9. We really need to identify a, b, and c to be able to do all the things we need to do with this. Because remember, we have to find the vertex, which we already know how to do, and then we also need to know what the y-intercept is. So what's our a value? 1. What's our b value?
-6.
Negative 6, because it subtracts 6x. And what's our c value? 9. Okay, we're always going to start with the vertex. So anybody recognize that little formula there? X equals negative b over 2a. What does that find for us?
The axis of symmetry.
Remember, that finds us that vertical line that cuts the parabola right down the middle. And what does it cross through always?
No.
What point on the parabola will the axis of symmetry always go through? What's that point called where the parabola makes its turn, you guys?
Vertex.
The vertex.
Oh.
So the axis of symmetry always goes through the vertex. So if we find the axis of symmetry, it's going to go right through that vertex. And remember what else we said? The x value of the vertex is going to be that number that we actually end up getting right here. So let's use our little formula, and let's put in our b value and our a value so that we get our axis of symmetry. So negative sign. For the b, we put in -6, and 2 times 1. Okay. So x equals negative -6 over 2. So x equals negative, what does this become?
Over 1.
Negative, what's -6 divided by 2? -3. So notice I just keep dragging that negative sign along that's in front. And then what does that become? X equals 3. Okay, so if we find the axis of symmetry, that's telling us the equation of the vertical line. That vertical line is crossing through the vertex. Every point on a vertical line has the same x value. What's that x value going to be? What's every point on that axis of symmetry? What's every point on that axis of symmetry? What's its x value going to be? 3. So that means the vertex has an x value of 3. So we now know, if we're talking about the vertex, we can now say right now, we know this much, that the x value is 3. We need to find the y value. So how are we going to find the y value? What do you suppose we're going to have to do? How about we substitute into the equation? Do you guys remember we did find the vertex back in another set of notes? We did find it, so we write down our equation, y equals x squared minus 6x plus 9. This is gonna kind of feel like doing table work right now. We have an x value of 3, we substitute it into the equation and we get our y value. So we're gonna put 3 in for x and see what we get for y. So we end up with 3 squared is 9. 6 times 3 is 18. 9 take away 18.
Is it done?
Negative 9.
Can't you make it so it's on the
Plus
opposite?
9 equals.
You can make it so
Oh,
it's
it's
at
divided.
Yeah, go ahead and make it at the opposites. You'll have 9 plus a negative 18, right? And what's negative 9 plus 9 now? 0. So we just found out that the vertex has a y value of 0. So our vertex is ordered pair 3, 0. So we just found the turning point of our parabola. We found a point to graph it with. It's a very important point of the parabola, because we have to be able to see where it's going to make its turn. Anybody have questions about that? That's something we actually did last week. You had an assignment where this is all you did is find the vertex of a parabola. Okay, well, let's work on the y-intercept next. What's the y-intercept of this one? Remember, it's up at the top. What was the first thing we said in this? The y-intercept is the c value. So the y-intercept, since c equals 9, right? Isn't that what we found out c is equal to? So since c is equal to 9, the y-intercept is what?
9.
Well, what's the x value for any point on the y-axis? No, the y-axis, you guys. What's all the x's equal to on the y-axis? 0. So the y-intercept is 0, 9. We now have 2 points. We need 5, right? That was an easy one to find. Now it says we're going to pick an x value between the y-intercept and the vertex and determine the y value. So let's go and put those two on the graph right now, just so we have a better idea of what I'm actually asking you to find right here. Let's go put ordered pair 3, 0 on our graph. There's our vertex. And let's graph our y-intercept, which is 0, 9. And what we're going to actually do is we're going to use symmetry to get another point that is actually symmetrical to that y-intercept. So you know what, let's just do a dashed line. Let's do a dashed line. Let's show our axis of symmetry right here. Remember, this is where it's going to, that's where it's going to make its turn. So we know that every point, and you should have recognized that in your tables for today, every point except the vertex has another point that has the same y value. There's a point symmetric to it. So this, we can get a third point really easily here. We would say this one is 3 units away from the axis of symmetry. Our y-intercept is 3 units away, so we go 3 units from on the other side and we plot ourselves a point. So we have the point that is symmetric to the y-intercept now. And we didn't have to do anything but count. It is 3 units away from the axis of symmetry to the left, so we go 3 units to the right. Symmetric points have the same y value. What's that one's ordered pair name?
6, 9.
6, 9. Okay. So if we made a table, it would actually be in there. Okay, now what we want is we want a 4th point, and then after we find that 4th point, we'll be able to use symmetry to get the 5th. So we need, if we picked an x value to the left of the y-intercept, chances are we'd be off the graph, wouldn't we? It's going to be a y value greater than 9. So let's pick a point that's somewhere between these two. This one has an x value of 0. The vertex has an x value of 3. So we need to pick an x value somewhere between 0 and 3.
You have 1.5.
You don't have to do 1.5. You can do 1 or you can do 2. Doesn't matter, which one do you wanna do?
We do 1, 4.
Okay, let's do when x is equal to 1. So what we're doing is we're looking for a point that's going to be on the U somewhere between the y-intercept up here and the vertex down here where it's making its turn. Well, there's only two x values in between there. We have when x is equal to 1 and we have when x is equal to 2. So we're just going to, you get to pick which one you want to use. So we're going to use when x is equal to 1. So we'll substitute 1 in. Do that. Oops. What happens when you take a day off of school? Everything goes wacky when you come back. Okay. So I'm substituting 1 in. Hopefully you kept working. And we get y equals positive 4. Is that what you got?
So I said even
Yeah, you did, didn't you? Okay, so this is ordered pair what? 1, 4. So now we'll go to the graph, and we'll put a point at ordered pair 1, 4.
Then on the other side.
And now you get to do the symmetry. So now you'll do 5, 4. There you go. There's your 5th point. Okay. And now what do you have to draw? Your line. Your U-shaped curve. Yeah, it's not really a line. It's a curve. So you draw your U-shaped curve with. Should it be opening up? Yes. Why?
Because the minimum, or the, because it's positive.
Minimum is positive. It's a minimum, not a maximum.
It is a minimum, but what's the real reason why it should be opening up? The A value is positive.
Yeah,
You have a positive A value. Oh, well, I don't know.
I was the minimum.
I guess I was so, tuned into something else. Okay, anybody got questions about what we did here? Okay, now I need to just give you a little heads up. What if the y-intercept and the vertex are right next door to each other? In other words, what if the vertex has an x value of 1? And the y-intercept, of course, has an x value of 0. Then, in between, the only x value in between that you might, you'd be like, oh, I have to use 1/2. No, you don't. You don't have to go between them. You can go outside. You can say, okay, well then I'm going to do when x is equal to 2. Or I'm going to do when x is equal to -1. You don't have to go between them. In other words, don't make it be fractions because they're miserable when you're trying to work with them in these equations. You always want to work with integer values for x. So you get to pick those x's. They don't have to be fractions, okay? Okay, let's go to the back side and see what we got here. Y equals -2x squared plus 6x plus 2. Always identify A, B, and C first if it's in standard form. Is it in standard form?
Yes.
Okay, what's A?
-2.
-2, which tells us our parabola better what?
Open downward.
Open downward. B is
6.
and C is
2.
2. Okay.
X equals B.
So remember we do x equals -b over 2a.
-6.
We're finding our axis of symmetry, which will tell us what our x value is of our vertex. And again, typically it's better to just let that negative sign keep coming along.
I don't like that negative sign.
Or you can assign it to the upstairs if you want. So I'm going to just let it keep coming along, and I'm going to end up with x is equal to a positive 1.5 or 1.5. Is that what you get?
Mm-hmm.
Can the vertex have a non-integer value for x? Absolutely it can. Typically, when we were learning how to define the vertex, I was just nice to found problems where they would turn out to be values that were integers. Okay, so now that we know that, what we need to do is we now know that the x value is 1.5. We need to find the y value. So we're gonna do, I'm gonna write down my equation first so I can substitute into it. And now we'll substitute into it. Now, some of you are, this is where you're going wrong. And I want you to stop and listen. Because it would be really, really nice if here, instead of taking 1.5 and squaring it first, we could take it times -2 and make it into an integer. Sure would be a lot nicer. But we can't. We have to do the power first, and then we have to go back and take it times that -2. So we gotta find out what is 1.5 squared.
I hate that. I feel like you should add, or you should multiply
I
the
know.
-2 times 1.5.
It would be so nice if we could, but we can't. We'll end up with the wrong value. So tell me what 1.5 squared is.
2.25.
2.25. If you have $1.50 6 times, how much is that? $9. Oh, goodness sakes. Okay. If you owe somebody $2.25, you borrow $2.25 from somebody twice, how much money do you owe them? In other words, I'm trying to multiply -2 times 225 without a calculator. You borrowed $2.25 twice from somebody. How much money do you owe them? $4.50, so it's a -$4.50 or a -4.5. Plus 9, plus 2. Employers are going to like you better when you can do math in your head instead of always having to go to that calculator. -4.5 plus 9, what is that?
Positive 550.
No, it's 4.5. Half of 9 is 4.5, you guys.
Oh, yeah.
Okay. So what's our y value of our vertex? 6.5, 6.5. So our vertex is 1.5, 6.5. So sometimes they're ugly, but it's okay. If it can be changed to a decimal, a nice decimal, then do that. That actually makes it easier. Sometimes they can't be, though. Okay, what's our y-intercept?
0.2.
And how do we know that?
Because it's their C value.
Our C value. So the y-intercept is ordered pairs 0, 2 because C equals 2. That's where we get that from. Okay, let's just go graph those 2 points right now so we can make a decision about where we want, what we want our next x value to be. So let's go graph the vertex, the y-intercept, and its symmetrical point. So we're going to graph 1.5, 6.5, is it, you guys? Yeah. Okay. So 1.5, 6.5, so it's going to be like kind of in the middle, right in the middle of the white box, right? That's our vertex. Does the vertex have a point symmetrical to it? No. In fact, the axis of symmetry, remember, goes through that. So it's going down like, I don't know why this is not following my finger, but okay. So looks like I got a whole bunch of points on here instead. I think I'll get rid of all of those. Okay. Let's put the y-intercept on there, 0, 2. Okay, how far away is this point from the axis of symmetry? How many units away from the axis of symmetry is the y-intercept? Going to the right. How far away is it? Right here. Here's our vertex, right here. Okay,
1.5.
1.5. It's 1.5 units away, so we're going to go to the 1.5, and then we got to go another 1.5, don't we? To get the symmetrical point. So where does it end up at? At ordered pair 2, or 3, 2, I mean. Okay. Well, it's looking like our parabola is going to open down. That's good news. Now we want an x value that will help us get another point.
Oh my goodness, I did this.
Now, I'm thinking that instead of finding one in between like I set up here, I suggested pick an x value between. I want you to know you don't always have to. Let's pick one that's not. Let's just see if we can get away with it. How about we try when x is equal to -1? Because this is going to have to keep going down, you guys, right? It's going to keep going down. So let's do when x is equal to -1 for the fun of it. Let's show that it doesn't have to be an x value between the y-intercept and the vertex. Let's pick one outside of it. So let's do -1. Y equals -2 times -1 squared.
So in all reality, you can pick whichever one you want.
You can, but what ends up happening is you do have to be a little bit careful because you might pick one that'll give you such a big y value it'll fall off the graph. You know, it won't be there.
It's not working out. Okay, just
Let's see what happens. So -2. What's -1 squared?
-1.
Just 1. 6 times -1?
-6.
-6.
well, there's my first problem.
There's you found your problem?
Yes.
Okay. -2 times 1?
1 or 2.
-2. -2 plus -6?
-8.
-8.
-6.
And -8 plus 2 is -6. So we just found ordered pair what?
-1, -6.
-1, -6.
Or something. I took, once again, I took the x times that 2 and
Yeah.
then -2.
Said it's 2 and squared it and got 4, didn't you? Yeah, can't do that. Okay, so -1, -6, go put a point there.
I got it.
And now we need the point that is symmetric to that. So remember, the axis of symmetry is right here. So we are really 1, 2.5 away from that. So we're going to go over 2.5, and we're going to end up at x equals 4, right? Okay. So use symmetry to get the other point. It should be exactly the same distance from the other side of the axis of symmetry. They share the same y value. The axis of symmetry is halfway between their x values. And there's our upside down
It looks like a rocket.
Yeah, I don't know.
Are we gonna have to do any of those 1/2 things in our work? I hate the halves.
I don't know.
Grab a ruler.
Okay, so any further questions? Anything still unclear about how you're going to find your 5 points to graph the parabola today?
Okay, I have
Or
one question. Where does the 1 come from, or the -1?
The -1, okay.
We threw a random number.
So here's what we did. We had the vertex right here. Let's see, I have a pen in my hand. We had the vertex right here, and we had the y-intercept and its symmetrical point. Okay. So we said we could have picked x equals +1, but then all of our 5 points would have been really close together.
Yeah.
So what I said is let's go on the outside of this point instead and get the point that'll be down further. So we picked x equals -1 because this is x equals 0. So we just went to the left one.
Okay.
So we get to pick our like our 4th point. We get to pick what we want next.
Okay.
Okay? Any other questions?
I did a +1 on that one, and